we continue our practice for the OGT in math by looking at coordinate geometry today. So the first thing we'll look at is a few notes. We won't dwell too long on the notes because maybe we'll try to practice as we go through the problems. But you do have to remember how to graph points if you're going to do working with coordinate geometry. So remember, when you name a point, it's an x, y coordinated pair. So the x is first. So this is the point 3, 4, which means to the right on the x and up 4 on the y. Here, for example, is the point -6, -1, which means on the x-axis we go left 6 because it's negative and down 1 on the y because it's negative. And if it comes out that you need to know, remember your quadrants are named in reverse order, counterclockwise order. Quadrant 1, where everything's positive, then to quadrant 2, then to quadrant 3, then to quadrant 4. You also may have to know a little bit about parallel lines, because when you're talking about the shapes, rectangles, etc., they have parallel lines. Parallel lines are identified on a grid or in coordinate geometry as having the same slope. So for example, this is up 2/3, this is up 2/3, therefore these are parallel. If you have to prove that something's perpendicular to have a right angle and is a right triangle, or maybe even in a square or rectangle, the slopes must be opposite reciprocals or negative reciprocals, as some say. So notice this line 1 slope is up 3/2, a positive slope. This slope of line 2 is negative, and it's also reciprocated. It's down 2, right 3. So those two slopes are opposite reciprocals. Up 3/2, down 2/3. Every time you multiply opposite reciprocals, you should get -1. But sometimes that proves that you have a right angle. You may need to use the distance formula. It's called distance. It also means length between 2 points, where you take x2 minus x1, square that, the same with y, then square root that. Basically, it is the Pythagorean theorem on a grid, where this represents the A amount, perhaps, and this could be the B amount. And then the whole thing represents the C, or the square root of c squared would be c. Midpoint is the distance between 2 points, is where you average them. You average the x values, which means you add 2 x values, divide by 2, average the y values, and that gives you the midpoint. On a grid, sometimes you can just locate it by looking. The Pythagorean theorem, as we just mentioned then, is to help find lengths of sides, especially slanted sides. Now, the distance formula is given to you on the OGT formula sheet, but the Pythagorean theorem is not, the midpoint is not, there's no slope formula. All you get is the distance formula. Here's some sample problems. These are in your note packet as well, if you've downloaded the coordinate geometry. So maybe we won't look at those. We'll look at some problems that are actually in the OGT. But you can always look at these yourself, or you can always call LDA if you want an appointment for more help. So here's our first problem. This is the way it came out when I snipped it from the state test. It's a little hard to see the actual shape. It said 4 points are connected with line segments as shown. And we have to find the slope of each side, and we have to determine if the shape is a parallelogram. And of course, we have to show our work and provide an explanation. Okay, so I've tried to enlarge that a little bit. It came out, maybe it won't be that blurry when you're looking at it from a distance, so that you could see it a little better. To me, it's a little confusing with all these numbers and then numbers on top of the vertices, but whatever. The quickest way to find the slope, if you're already on a grid, is to just do the little slope triangle. So if I want the slope of AB, I just go up, in this case 2, and over 3. I went up 2 blocks and over 3 blocks. So the slope of AB is 2/3. Then I say to myself, I think the slope over here is the same. So I'm going to do this slope as well. So from D to C, I also end up going up 2 blocks and over 3. So this slope is also 2/3. And remember, if the slopes are the same, that means these two lines are parallel. And I can check, I'm going to check BC. from B to C, I only go up 1 and over quite a bit. 1, 2, 3, 4, 5, 6, 7, looks like 8. Looks like I'm going up 1 over 8. Check to see if I'm doing the same from A to D. From A to D, I'm also going up 1, and I do believe I'm going over 8. Up 1, 1, 2, 3, 4, 5, 6, 7, 8. Yes. So that would be considered, I think, my work. So instead of using the slope formula to subtract my points, I instead have used the grid to count up and over. And so this is what I would suggest for my answer document. Slopes from the grid, AB was 2/3, BC was 2/3, BC and AD were both 1/8. And here's my reasoning to determine if this is a parallelogram. Since opposite sides have the same slope, they are parallel. Since opposite sides are parallel, ABCD is a parallelogram. So I've included them. I'm not saying that I just didn't say the sides are parallel. I pointed out they have the same slope, which means they're parallel. And I've also said opposite sides being parallel is the criteria for a parallelogram. So I think I've got my 2 points for that problem. Next problem here, it says a circle is sketched on a coordinate plane with the center at 6, 8. The circle passes through the point 0, 5. Which of these expressions could be used to find r, the radius of the circle? So sometimes if I need to, I do a little rough diagram. It doesn't have to be perfect. The center of this circle is at 6, 8. It goes through the point 0, 5. So my circle looks something like this. So I have a circle. Okay, so if this is the center of the circle and it goes through this point, that distance between those 2 points would be my radius of my circle. So it asks me which of these expressions could be used to find the radius. Now, if you remember one of the notes I had given you earlier, so this is really nothing more than the distance formula. The distance formula finds the finds the length between 2 points. So we subtract the x's, square it, subtract the y's and square it, and let's see if that looks like this at all. Here, our x values are 6 and 0. Remember, the first part of the point is your x's. So I need to subtract 6 and 0. And actually, there's only one equation doing that. This is the only one subtracting 6 and 0. Then I should also be subtracting 8 and 5, yes. And the subtraction then becomes squared. We've got that, and it's square rooted. So A is it. It's just asking you to use the distance formula with those 2 points. And this is actually pretty simple for you in a way, because like I said, the distance formula is on the OGT formula sheet. 3 vertices of a quadrilateral are -1, a -1, 1, 2, and 5, 2. And they also have them marked for you on the grid. It says, when used as the last vertex, which point would make the quadrilateral a trapezoid? We gave a little bit of notes from Angles and More, the section on Angles and More, and those had the picture of the trapezoid. I didn't really bring that with me, but most of the time when you draw a trapezoid, they usually draw the isosceles trapezoid, where these 2 legs are the same, and these are your bases, which are parallel lines. So, of course, they could have the trapezoid turned in any direction, but I don't think they did that in this case. So you could estimate where you think the point is, or you could put the points on the grid and say yay or nay. Like, for example, the point A, 3, 0. If I mark 3, 0, I do not think that those 4 points give me a trapezoid, because I don't think that I get any parallel bases, because this is straight across, but this is moving up. And this is not the same either. This is up 3 over 2. This is up 2 over 2. So I say no. Let's try 3, -2. 3, -2 puts me down here. Again, this is a little off, I would say. These are not parallel. This is straight across. This is not. And these are not either, because this is, we said, up 3 over 2. This is now up 4 over 2. So nothing's parallel, does not make any kind of trapezoid. Negative 5, 0 is way over here. If I try to connect these three given points that are in black and this, I don't think that I get anything that's going to resemble a trapezoid. I do believe the correct answer is 7, negative 1. Let's take a look at that one. 7, negative 1. Notice now, these are lining up and as those lined up. So those are my two parallel bases, and I do end up with actually an isosceles trapezoid. So by doing the work, checking all the points, or if you're very good with your shapes, you may have just said, oh, I think the point goes here, and there it is, 7, negative 1. Correct answer. The vertices of a quadrilateral are 2, 2, 4, 6, 8, 2, and 10, 6. Now, they did not put these on here. So in order for us to answer this question, I think it would be easiest if we were to put the points on the grid. So let's do that. 2, 2 is 2 right and 2 up. 4, 6 is 4 right and 6 up. 8, 2 is 8 right and 2 up. And 10, 6 is 10 right and 6 up. So most people can probably look at that and say, ah. We can choose between parallelogram, rectangle, rhombus, square. I think we know it's not a rectangle or a square because these are not right angles. You see an acute angle down here, an obtuse. So it's parallelogram or rhombus. A rhombus, by the way, is a fancy parallelogram with the sides the same. So you might want to double check. I think maybe you could tell by looking that this certainly looks longer than this. But if you want to try it for sure, this you can just count blocks because it's a horizontal line. So it's 1, 2, 3, 4, 5, 6 units. But this is a slanted line. So we could practice our Pythagorean theorem. We could make a right triangle out of this, where this could be A, this could be B, and this could be C. So A is 2 blocks, B is 1, 2, 3, 4 blocks. So if I do that Pythagorean theorem rather quickly, quick reminder, the Pythagorean theorem again was square the legs, square the A, square the B, that'll give me the C number squared. So if I square 2 and square 4, that's 4 plus 16, which is 20. Now that doesn't mean this line is 20. That means that line is the square root of 20. And I'm sure that the square root of 20 is not equal to 6. I could put it in a calculator if I needed to, but all I really need to know is whether it's equal to 6, because 6 would be the square root of 36. So they're not the same. These two sides are different, so that makes it a parallelogram. 2 longs and 2 shorts. Okay, this is an extended. This was a 4-point problem, but there was a lot to do. It says in your answer document, show that the segment connecting the midpoints of AB and BC is parallel to AC and 1/2 the length. Show your work or provide an explanation. Show that the segment connecting the midpoints. We don't have the midpoints, so we're going to have to find them. Now, in this case, since the midpoints turned out nicely, I tried to use the grid so I could avoid a lot of work of like adding numbers together, etc. Although if I need to, I could apply the midpoint formula. But again, this is not given to you. So I just kind of scanned this from A to B, and I said, I think that looks like the middle. So I said, let's see if that's not the middle. I can be sure now if I check. To get from A to here, I went up 3, right 4. If the same thing happens to get from here to there, I know I'm in the middle. And it is indeed up 3, right 4. So I'm convinced. So for my work, I'm going to say from the grid, I can see that this is the midpoint. And the name of that would be the 0.55. So that midpoint is 5, 5. If I'm lucky, I can get another good midpoint for line BC. And I'm scanning the line. I say this certainly looks like the middle, but I want to be absolutely sure. And if you wanted to, too, as proof, you could do this to show work. Then this is over 1 down 2, but this is also over 1 down 2. So I am sure that's the midpoint. This is the point 10, 6. So I now have my midpoints. Now my job is to show that the segment connecting these two guys is parallel to AC and half its length. It certainly looks parallel to me. What I can do, though, is I may end up using the points this time to show if the lines are parallel or not. This point of A was 1, 2. This point for C is 11, 4. So this to find the slope, oops, I can see some of that's writing on top of that. Sorry about that. It said here's the midpoint. The midpoint from AB, as we mentioned, was the point 5, 5. The midpoint from BC is 10, 6. I called them M1 and M2. I just made up names for them for those points, but they're midpoints. Then I said this M1, M2 has slope 1/5. So again, if I go up and over for this line, I went up 1 and over 1, 2, 3, 4, 5. So that slope was 1/5. AC, I went up 2 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But up 2 over 10 simplifies to 1/5 as well. So remember we talked about parallel lines have to have the same slope. So I have just shown that these two lines are parallel because they have equal slopes. So I showed the slopes, said the slopes are equal, so the lines are parallel. Then there's no real shortcut, I guess, for finding the lengths. I chose the distance formula since it is listed on your your formula sheet for the OGT. So I took my points. This is the point, the midpoint, and recall we named these points. So these are the x's being subtracted, and these are the y's, 5 and 1, 5 and 2. Oh, I'm sorry. No, I'm not subtracting those. Excuse me. I have to find this segment here and this segment. So I'm doing 5, 5 and 10, 6. So 10 minus 5 and 6 minus 5. So here's my 10 minus 5 and my 6 minus 5. So I just do the math. You have to subtract because it's in parentheses. This gives me 5 squared, which is 25, and 6 minus 5 is 1 squared. This should say 25. Excuse my typo here. That should be a 25. And 25 plus 1 is 26. Okay, the square root of 26 is about 5.1. Then I did my A to C, which is the point, the x coordinates are 1 and 11, and the y's are 2 and 4. So here's my 11 and 1, and my 2 and my 4. 11 minus 1 is 10. 10 squared is 100. 4 minus 2 is 2. 2 squared is 4. That gives me the square root of 104. These have to go into the calculator, which is approximately 10.2. So I hope you can tell by looking that 5.1 is half of 10.2. So it says the length of M1, M2, which would be from one midpoint to the next, is half the length of AC. So I've done everything they've asked me to. I found those midpoints. I showed that the two lines were parallel, and I showed that it's 1/2 its length. So I do believe I would get 4 points for that. Quite a bit of work, though. Okay, here's a picture of, looks like a kite, maybe. Points E, F, G, and H are midpoints of the sides of the quadrilateral AB, CD. So we have a quadrilateral, the huge outside one, and they said E is the midpoint of this side, F's the midpoint, G's the midpoint, etc. Remember, midpoints are in the middle, but they also kind of cut the segment in half. It says if AC, this whole long line, is 12, and BD all the way across is 8, they want the perimeter of this quadrilateral inside. So since these connect the midpoints, and this connects the whole thing, this would be half of this. If this was then 8, this would be 4. And of course the same would apply to this one, because it would be half of that line. So this will be 4. Again, these are midpoints connecting, so this line is half of the long AC line. AC was 12, so this is 6. Same thing applies on this side. We're actually using that mid-segment theorem of the triangle, kind of that we just proved in this last picture. If you connect the midpoints of the sides, this is half this distance. And that's what we have, midpoints of sides, and then this is half of this. So then the perimeter, don't forget to add up all 4 sides for perimeter, 4 plus 6 plus 4 plus 6. We get the perimeter to be 20. The coordinates of triangle KLM are as stated, but they also drew the shape for us. It wants to know what type of triangle it is. Obtuse isosceles, acute scalene, right isosceles, or right scalene. As mentioned before, in our angles and more section, we have notes on what these mean. If you recall, obtuse is an angle greater than 90. Isosceles means 2 sides of the triangle the same. Acute is less than 90. Scalene is no sides the same, or all 3 sides different. Right isosceles, 2 sides the same, but in a right angle. Right scalene, a right angle, but all 3 sides different. So, since we have a grid, I was going to make my little slope triangles and see what was going on. So I said to get from K to L, I could go up 1, 2, 3, 4, 5, 6, and over 2. If I do from L to M, instead of going down, I'm going to go over first, then down, since I don't get not to get inside that triangle. So I go over and down. I go over 1, 2, 3, 4, 5, 6, just like that's up. But I go down 1, 2, 3. So if I was doing the Pythagorean theorem with these being right triangles, these two could not be the same because they both have a side of 6, but this is a 2 and this is a 3. So this line is slightly longer than that. Let me check this third side. I'm going to go over and come up. I'm over 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3. Well, the 3 is the same here, but this is 8 rather than 6. And so since this is longer than that, and this now would be longer than this, all 3 sides are different. So that means it can't be any of these isosceles words. So it's either an acute scalene triangle or a right scalene triangle. Now, if it's a right triangle, it has to be a right angle. So I think they did this on purpose. I think you can tell by looking that this is not a right angle. You see plenty of right angles all the time. The corner of your paper is right. If I try to put this corner of my paper, I cover that whole thing up. This is the right angle, so that's much smaller. Same thing here. If I try to line up my paper in that angle, it's the right angle of my paper is much bigger than that angle. So hopefully you can tell by looking. No. That looks suspicious. But again, if you recall, in the notes we took in the beginning, it mentioned that perpendicular lines, which is what's required to make a right angle, have to have opposite reciprocal slopes. Well, when I drew these little triangles, I kind of have my slope. Now remember, though, slope is rise over run. So the KL slope is up 6 over 2. So the LM slope is fall 3, run over 6. Run over 6, fall down 3. So that's negative 3 over 6. They're close to being opposite reciprocals, but not quite. This is a 2 and that's a 3. So by looking, you might think it's right, but it's not really a right angle. So it's an acute scalene triangle. But again, if you actually do the slopes and check them out, you can be very sure of your answer being correct. This interesting problem from 2008. This one I thought was quite difficult, and they certainly didn't help you make it very easy. It says, in honor of the new millennium, Stephanie buried a time capsule in her front yard. She sketched the location of key landmarks as shown below. She noted that the capsule was buried equidistant from the oak tree and the elm, also equidistant from the mailbox and front door. Which pair of coordinates is the closest estimate for the location of the time capsule? So some you could kind of look at some of these and say, here's 4G right here. Does that look equidistant from the oak and the elm? It certainly looks closer to the oak than it does to the elm. So I don't think so. If we went 4G, that distance is, I would say, is not the same, because it's supposed to be the same between the oak and the elm, for one. It's also supposed to be the same between the mailbox and front door. Mailbox and front door, it looks farther from the mailbox than it does from the front door. So I say no. 7H. 7H puts me right here. Ooh, that looks pretty close. Oak and elm, front door and mailbox. That looks pretty reasonable. 8G. 8G. Uh-oh. That point's really close to 7H. So, although this looks a little farther this way, so I'm not sure. It looks a little closer, actually, to the front door than it does to the mailbox. So if I had to guess between these 2 points, I think that 7H might be a little better. Let me look at this last point first before I make any decisions. Let me look at, let's do 10H. 10H is right here. Wow. You can definitely see that that is much closer to the elm than it is to the oak. So I say no way. So it's got to be one of those. There is a way to identify it exactly, because to be equidistant, you have to be on what they call the perpendicular bisector. The first thing I'm going to do is I'm going to like kind of connect the oak and the elm for one. Okay? The oak and the elm then has a slope of up to over 2, 4, 6, 8, 10. Up to over 10, which reduces or simplifies to 1/5. So my perpendicular bisector of this line would have to have the opposite reciprocal slope of -5/1. And also, if I go here, I can see that this is the midpoint of the oak and the elm distance there. But then I would draw a line down 5/1, 1, 2, 3, 4, 5/1. Then I could go backwards, up 5, 1, 2, 3, 4, 5/1. And that would be my perpendicular line. And when I draw that, which point is closer to this perpendicular line? My point 7H or my point 8G? And we see that that is closer. So I am convinced pretty much that it would be point B. I could do the same for the mailbox and front door, although that was not nearly as nice, because that slope, or if I check it this way, I could run over 3, that's my bottom number, run over 3, and go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can't even find a good middle, because 11 doesn't divide by 2, neither does 3. So the middle is somewhere 1, 2, 3, 4, 5.5 over. So this is the middle. And then I could draw a slope that's the opposite of that, and I would go this way, and I'd say they have to be close. And then when I draw that line, it appears that both of these are very close to that line. However, this point was closer to the blue line than the blue dot was. So I would say since they're about tied for the perpendicular bisector on orange, if I actually draw it, I don't have much room to go up, go down 3 over 11, so I'd have to like try to guess at that. Be something like that. And so these both are pretty close to the orange line, but I said this is closer. So, but again, if you were going to guess, I would hope that you were guessing between these two. That was a pretty difficult question. And we have one more question here for coordinate geometry. It says points R or Q, R, and W are plotted on the coordinate grid, and it wants to know where point Z should be plotted so that the parallelogram QRWZ is formed. If you recall, we did see a parallelogram already today. We said we thought that was a parallelogram. Notice, two sides parallel in this direction, two sides in this direction, no matter which way you turn it, two parallel sides. So you could, some people are very good at just finding the dot. For example, I can see that I had to go from here to here, I had to go up 1 over 4. So I would say if I was here and went up 1 over 4, I said that ought to be my point. So I think that's it. And that point has the name -1, -3. And there it is. But if I wasn't sure about doing it that way, if I wasn't real good at it, and oh, and by the way, if they call it QRWZ, that tells you the order you connect your points. You go from Q to R, R to W, sorry about that, R to W, and then W down to wherever Z is, and then Z back to Q. So I know that much at least. So if I were to put the point -2, -6 on the grid way down here, I'm going to say, how is that going to make myself a parallelogram? That almost makes it look like a trapezoid. Maybe not quite. So I don't think that would make a parallelogram. If I wanted to go to 3, -2, I would say, well, how does that make myself a parallelogram? Don't think so. That again looks like it could be some sort of maybe trapezoid. And if I tried 2, -1, again, that doesn't look like a parallelogram. So I do believe it is the -1, -3. And let me finish drawing it so that I can see it and convince myself. Now that certainly does look like a parallelogram. We did check these slopes. These were up 1 over 4. Let's check this. Up 1, 2, 3, 4, 5, 6 over 2. 6 and 2. Let's see if this is the same. 1, 2, 3, 4, 5, 6 over 2. Yep. So for sure that's the point, 1, 3. And that ends then the coordinate geometry portion of our review for the OGT. Please look forward to more videos on some other ideas like the polygons and polyhedra. We're going to have to take a look at data analysis and probability. I wish you good luck on your Math OGT.